Thank you. Okay, you can hear me. Yeah, this is like testing in production with everything, with the stream. Okay, so my name is Zlatko. I work as an iOS engineer for like 15 years or something like that. And yeah, I mean, not sure if, I guess you've noticed, but I really became a fan of the Point Free guys, let's say recently in the last year and a half, 2 years. So today I'm going to present something from, of course, their series of videos. By the way, a small side note, I'm going to present from a video because Keynote had issues with the screen mirroring and everything, so it's going to be like play pause. And yeah, let's continue. So I'm going to stop here. As I said, this topic is part of the Point Free guys series of videos about observation. So they're talking about the past, the current observable framework that went out this summer, right? And we'll talk about some issues with the previous solution, with the current solution, and yeah, some fixes that they actually introduced. I'm gonna share a QR code of this series later on. You'll be able to scan it, and if you're interested, to watch them. So let's start with how it was before. Basically, observation was introduced with the first version of Swift, right? The point was that we needed a way to automatically detect whenever something is changed so that it can be redrawn on the screen via Swift UI. So first we will talk about state. So state is basically a property wrapper that detects changes on the property, and it triggers automatic redraw of the view, therefore applying the new changes. This state is basically like, because it works with value types, which is the view itself, it still needs to hold some kind of a reference to the current state. So basically there is some magic happening behind the scenes where you set a state to a view for the first time. The next time it's not gonna set a new state, but it's just gonna observe the changes of this one. And even though you set it on the view itself, again, the state itself doesn't change. The view redraws. It is created again, but the state doesn't change. Okay, so let's continue with this. So there are a few problems with this. If we use the state within the view itself, you can't really. There are a few issues. For example, you can't really test or write a good unit test because the idea is that you need to separate the business logic from the view itself, so that if you want to write unit tests, right? Also, for example, yes, using addState as a property wrapper is good for something like, let's say in a button you want to keep a state where the view is pressed or not, whether the view is deactivated or not. But if you want something to send from outside, you can't use this property wrapper. And yes, if you want to fire a side effect, like, I don't know, a network call or anything like that, it's not going to work with this solution. So if we start to separate, I'm going to stop here. So if we separate, let's say, the business logic from the view itself, let's say we create a class which is some kind of a view model, right? And there is a side effect, like in this dummy example. There is a network call, and after the network call, you run update of the title on the main actor. Sure, but keep in mind that this is a naive solution, because if we still use here addState as a property wrapper, it's not going to work. Let me see. I think, yes, this is not going to work. The problem is that this property wrapper only detects changes on the property itself. But if you use a reference type like class, even though something changes within the class, the reference itself doesn't change. So basically, you will not perceive the change within the class itself, so that the system is notified to redraw the view based on the latest state. Of course, for that reason, this observed object was introduced. I'm gonna allow this to play it out. So basically, observed object is a new kind of property wrapper where there is a requirement on the property itself to implement the observable object protocol. And there you can set another property wrapper in each individual property that you want to observe within the class itself. So here now this would work, because if you change the title, this published will automatically send, if you know, basically object will change signal, let's say, and this then informs the system, SwiftUI, to redraw itself. But with this, let's say, old system now, there are still issues. So I'm just gonna let this. Okay, so basically these are there are many issues for sure, but let's say this is the main of them. If you this marking of properties as published can lead to either over or under observation of a model. What does that mean? So, for example, let's say with under observation, if you have a private property which is this timer task, but then you have, let's say, a computed property. First of all, you can't apply the published property wrapper on a computed property. So whenever, let's say, the timer task changes, let's say becomes nil, of course this property wrapper will change, right? But because you can't mark it as published, you have to mark your own private property as published, and then it becomes basically a mess of you're not sure what you should mark as published, what you shouldn't. There is also the other way of where basically just to be sure you will want to mark all the properties with published, but that means that, let's say, even if a property is not shown in that view, let's say it's hidden for some reason, and if it's marked with published, then that means that if you change this property in the background, it's gonna change. It's gonna send this object will change event, and it's gonna trigger a redraw of the view, even though the view doesn't depend on it. And for example, if you have something that's being, let's say, refreshed multiple times a second, it might lead to, let's say, some performance issues where you refresh something that you don't even need to be refreshed on the screen. So basically, I don't want to hang around too much with observed object. Okay. Another point that I wanted to point out with this, this is called nested observation, where you have, let's say, a feature within a feature, and then, let's say in this, again, dummy example, you're in the body itself, you're reaching into the model, which is the up model in this case. You're reaching into one of the features, into the title, and you just are interested in the count, nothing else. This doesn't work because, first of all, you would think that, yes, I need to mark my models as published, but for the same reason that state with the view model didn't work, these features from the previous example, if you remember, were classes, basically reference types. So if anything changes inside, let's say the title, the reference type itself, the reference doesn't change. So that means the feature doesn't change. That means that you don't know about this change and it's not going to be redrawn. So there is a solution for this, which looks like, I'm going to play it out so that it's kind of clear with everybody. Basically, you need to subscribe to the events coming from the first feature, which is object will change, implement a sync, and then you need to send your own object will change event. And of course, you need to take care of holding on to this sync, basically in this cancellables bag set. And yeah, now you can see that this is becoming like a kind of a small nightmare. And keep in mind that this is only implemented for first feature. If you want to implement for the second feature, you need to do this same thing again, which started to become cumbersome, let's say. Okay, so I think now we can move to the new framework that was introduced this year, which is observation. I'm not sure, is anybody aware of observation as a framework? Did you watch WWDC this year?
Just a second, I think that we don't hear you anymore.
Test. You don't hear me here? Test. Okay. Again. Do you know about the new observation framework that was introduced this year? Okay, apparently not. Yeah, so it was introduced, and basically this framework is trying to solve all of these issues that I mentioned before. Basically, the whole idea is, first of all, that this is a separate framework. So even though the main use case of this framework was for Swift UI, you can use it for other use cases as well. So let's see how this looks actually. So first of all, I'm going to show you how it used to look like. So we still have this observable object protocol conformance. We have the property wrappers and here and also here. But with this new observable framework, is it okay? No, it's not. Can you hear me like this?
Yes.
Right? Okay. Then I just want to point out that now observation becomes, let's say, a lot less taxing on you as a developer to think about, because all you need to do is import observation as a framework, and you need to mark your view model as observable, and you should be good to go. Basically, it works like magic. So observable is a macro. You know that macros were introduced this year as well. Basically, what macros allow you is to add a lot of code behind the scenes that you don't care about, you don't need to see. But still, you can expand macros within Xcode 15 and onward, and you can see what it adds as an additional code. So let's see what's hiding behind the observable macro. So basically, let's say this is the condensed view model. And if you right-click and expand macro in Xcode 15, you will see something like this, which is quite a lot of code. But yes, I don't want to, let's say, burden you with all of this code. The key things to remember here is that it adds this register, which is basically behind the scenes. It's like a whole blob of things that it remembers. That's it. and it adds this access and with mutation methods. You'll see later on how they are called, let's say. And it conforms this view model to the observable protocol behind the scenes. So this is something that you don't see. Let's continue, because it adds some additional macros. For example, this observation ignored means that it's going to be ignored by observation. But we want now to expand this observation tract macro, and we'll just do that. What's important for you to remember here is that for each property, it automatically adds this observation tract macro. And that actually makes this property, if you have it like a normal property, it converts it to a computed property behind the scenes, and it adds an actual property, which is the underscore of the title of that, of underscore name of that property. And what it does is when you get this property behind the scenes, it calls this access method that we saw previously. And when you set it, as you set a new version of this, it calls with mutation. So long story short, what happens is basically this registrar that we saw before takes note of who is accessing and who is so accessing this particular property. And when anybody mutates this property, then it will basically check within its, let's say, list or dictionary. Whoever accessed this property, it's going to notify them afterwards so that automatically the view is redrawn. So there is a lot of magic happening behind the scenes, which actually it's not magic when you peer into it. So this is my point that I wanted to let's say transfer to you, that it's all that. It just takes note of who accesses this property, and when this property is modified, then it just notifies all of those, let's say, views. Okay, so now let's just talk about observation again, but let's say a summary of this, a short summary before we continue. So now observation allows you to just hold on to the model itself within the view by a simple let. Or if you want to hold it yourself, you can use addState as well here. And all you need to do is mark the class, the view model, with observable. There are a few problems though. I'm gonna move this here. So let's discuss about these problems. This is something that you need to be aware as engineers. Observable cannot be applied to value types. That means you cannot apply it to enums, you cannot apply it to structs. Problem is that that means that now when you model your model, you need to use classes instead of structs if you want to have fine-grained observation of your properties. For example, let's say I'm going to go back a bit. Let's say here. Within your view model, you have another, let's say, property which is a model for an employee. And let's say that this employee has something like 10 fields within it. So what are you going to use for that employee? Do you want to use structs or do you want to use classes? Because the whole point of Swift when it was introduced was that structs and actually value types becomes, let's say, citizens of first order, which meant that you can add methods, functions to structs, to value types, as well as you were able to add to classes before. a lot of times, oftentimes, you want to use structures to model, let's say, the employee, because I'm going to return now to this point. Value type structures have equatability and hashability built in. That means that when you write a unit test, and let's say you want to test whether a model changed, let's say some property within the employee changed, because value types have equatability built in, it's very easy to basically check the first version of your employee, let's say, and the second one, compare them, are they same or not. That's not true for reference types, for classes. The problem with reference types is that because they not only hold pure data, they can also hold behavior. That means that you can have side effects within them. Let's say a class can hold the timer as well. That's a problem because, let's say, even if you try to implement equatable on a class, you can't be really sure what properties you want to use to define that this, let's say, class of employee is the same with the other one. Because if you have a timer within it, are you going to use that timer for the equatability calculation or not? So it's a lot more complicated, and that's the biggest problem, that when you use observable, and whenever, again, I'm going to return to this, whenever, let's say, any property within your employee changes, one of those 10, it's going to trigger redraw of the view. And again, we go back to, let's say, over observability in that regard. Bottom line is, sure, maybe tomorrow you'll not care too much about over observation, but keep in mind this, that if you see that your view is being redrawn really often, that might mean that some property somewhere within value type is being modified, that it's not even needed for the view, and it can cause to redraw the view itself. So I'm gonna continue from here. Yes, observation is iOS 17 only. So that means that, yeah, you can't use it if you need to support older versions of iOS, which of course oftentimes you need to. So there is basically a kind of a solution which is called perception. This is again basically a framework built in the likes of observation by the point free guys, but you can use it from iOS 13 and onward. So that means that even today you can drop support, or you can stop using observable object, and you can start using perception. There is one small exception. I'm not going to tell you this. Find it out yourself. It's not terrible. Basically, you need in the view to add an additional, let's say, wrapper around the view. That's it. That is it, actually. I'm just gonna leave it played out to the end, because this QR code is actually the link to the presentations that I mentioned at the start of this presentation, if you want to check it out. And yeah, I guess questions.